Oh, wow. That's empty. Oh, time. Timer. Hello. Tyler, can you hear me?
Yes, sir, I can hear you.
Evidently you can, but I can't hear you. Okay, try again.
Can you hear me?
Now I can hear you. There we go.
Cool.
Always have to check which speaker it's coming out of. So go ahead and put your name in chat, if you would, please. Thank you. The focus is just going nuts over there. Isn't it? I did this to one of my remote only classes. And I asked them to tell me why do you think I put those numbers in? And people went, found it. Didn't even know it was lost. People on Zoom can probably guess quicker than here. But I used to do this when I taught high school math. When we had the overheads, I would write a number on the overhead. And ask students why that number? And they would start telling me everything they knew about the number, or anything they could find out about the number. And some of the guesses were pretty wild. And it's just a measuring stick. With the overhead, I write the number down there, and then I adjust the focus. That's all I would do. So I wrote these numbers here just to kind of determine how my field of view on the Zoom. That's all. It's no biggie. But yeah. But high schoolers, we've got to keep them on their toes. Throw things out at them like that all the time. Okay. I don't know if I started this section last time or not. Before exam 2. Right triangle trigonometry. Basically, this is called solving the right triangle. How does this program? Running my battery down. Okay. So to find the trigonometric functions of acute angles, using right triangles, use complementary angle theorem, and to solve right triangles, and then what used to be called word problems, the applied problems. Okay, the trig ratios, these shouldn't be new. If you have a right triangle, these are the definitions of sine, cosine, tangent, cosecant, secant, and cotangent. Where cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent. So you designate what angle you're working with, and then the opposite side over the adjacent side. So in this picture, that's what it would be. We usually name these angles. This would be angle B down here. That would be angle A up there. And the right angle would be angle C. Because the opposite side corresponds with its opposite angle. And for the purposes of the trig functions, that works out. Okay, so find the value of each of the trigonometric functions in this triangle. So the first thing to do is to find out what the opposite side is. Okay, we're not trying to find this angle. We just want to find out what sine of that angle is, what the cosine of that angle is, and what the tangent of that angle is. And once we find those, we can find the cosecant, which is just the reciprocal of sine, and we can find the secant, which is just the reciprocal of cosine. And same thing with cotangent. It's going to be the reciprocal of the tangent. But first, we need to find out what this side is. So we use the Pythagorean theorem, and we know the hypotenuse in one of the sides. So we do the hypotenuse squared minus the known side squared, and we square root it, and that will give us the opposite side length. And so 13 squared, which is one of the first 16 perfect squares, 169 minus 25. And that's going to give us a square root of 144, which also is one of the first 16 perfect squares. And that is 12. So the opposite side is 12. So writing those ratios, it should be easy. The opposite side over the hypotenuse is the ratio for the sine. So that'd be 12/13. The cosine is the adjacent side over the hypotenuse, or the length of the adjacent side over the length of the hypotenuse, which is 5/13. And tangent is the length of the opposite side over the length of the adjacent side. So that's going to be 12/5. You don't need to punch it into the calculator. All you need to do is write it as a fraction and reduce it if necessary. And cosecant is the reciprocal of sine. So that's 13/12. Secant is the reciprocal of cosine. So that's 13/5. And the reciprocal of tangent is what cotangent is. So that's 5/12. So there we have the 6. The values of the 6 trigonometric functions. And all we had to actually calculate was the length of the missing side.
We're SOHCAHTOA, right?
Yeah.
Yeah.
I never really learned that algorithm, that SOHCAHTOA. I
Mhm.
really haven't. I don't deal with that because I was never taught that, and I've never had to deal with it in the classroom. So SOHCAHTOA.
Opposite over adjacent for tangent.
S is opposite
Sim-
over hypotenuse. Cosine is adjacent over hypotenuse.
And
And
tangent is
tangent
opposite
is
over
opposite over adjacent.
adjacent.
Yeah, I know where the letters come from. It's just, I just don't use it.
Yeah.
It's not necessarily in my lexicon of things to use. All right, the 2 given sides, and so yeah, so they go through and they go through that, and then taking the square root. And notice when they took the square root, they didn't do plus or minus because we knew the length had to be positive. So they only took the primary square root. They didn't consider the negative square root. So the opposite side is it has a length of 12. And there we go. Now the lengths of the 3 sides are known. Use ratios to find those triangles, those sides. And then the other 3 were the reciprocals of the first 3.
Some basics.
And this is just basically a review of high school and high school mathematics, and also a little bit into 8th grade mathematics. But no, we didn't do this until, well, I didn't do it until Algebra 2 is when we did this stuff.
Yeah, that sounds about right.
Also when we started doing,
That's how you measure the ladder. It's got this much of an angle. What's the distance?
Yeah.
I remember those terms.
that's geometry,
Oh, that's yeah.
but yeah.
It does a little bit with. Oh, that's more
In high
Pythagorean.
school geometry, we don't do much with the trig functions. All right, I don't you won't see a problem like this from me, but you might see it in the homeworks. So basically, they want to maximize the volume of water that goes through the rain gutter. And so they want to know what these angles need to be to maximize this. This here. And so the area, this area in here, is determined by this formula. So you take the sine of theta and you multiply it by the cosine plus 1, the cosine of theta plus 1, and then you multiply that by 16. And so we look at for 30 degrees, 45 degrees, and 60 degrees. Now, best guess estimate, which one do you think? Which one do you think would maximize the volume? Or give the most volume?
Of the degrees you're saying?
Yeah, the degrees. This is about a 30 degree and then a 40 degree and then a 60 degree. Which one would give the most area in that?
Well, if you flatten it out, the way you got it on top, right? If you flatten it out the way they have it on top, that'll give you the most volume.
This?
Yeah.
It doesn't contain anything. It just goes everywhere.
Oh, well, then just 1 degree above that, which would be 179.
So then you would just have a very small.
Yeah, but that's the maximum volume, right?
Nope.
Oh. Oh, all the way 45.
At 45 degrees. Okay. Well, let's look at. So you're
30.
putting 30 degrees in there. No, they're gonna calculate for all three. For 30 degrees, all right, 30 sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2 plus 1, and then end up multiplying by 16. So we're gonna end up multiplying by 8, and becomes 4 square roots of 3 plus 8, which is approximately 14.893 square inches, I think is what it's in. Yeah, square inches. And then if we do the 45 degrees, so both cosine and sine of 45 degrees are 2 square roots of 2, are square roots of 2 divided by 2. And then we add 1 to the cosine and then just multiply through by the 16. And so that ends up again being 4 times the square root of 2 plus 1. I mean, plus 4, why 8? Because you're dividing by 2 twice.
Twice.
Yeah. Dividing by 2, and then I am going to end up dividing by 2 again. So I think that's incorrect. And then we have about 19.31 square inches at a 45 degree angle. So it's more than the 30 degree. And then we look at the 60 degree. Sine of 60 is 3 square roots. I mean, square root of 3 over 2. And cosine is 1/2. And so this is going to be 3/2. And that's going to be 12 square roots of 3. And punching that into the calculator, you get approximately 20.78 square inches, which would also give you your maximum would give you the most volume of those 3 angles. So with rain gutters, you want to move as much water as you can move. All right, complementary angles. The word complementary, notice there's a spelling difference between complementary angles, and if you're being complimentary, then you're spelling it with an I. So complementary with an I means you're being whatever, you're being nice. Any person compliments. Okay. But which is different, and that's with an I. This is with an E. Complementary angles are angles that add up to 90 degrees. So with a right triangle, two of the angles are complementary because they have to add up to 90. So you can get 180 out of the triangle. So here they're talking about complementary angles. The cosine and sine of complementary angles are equal. The sine of B and the sine and the cosine of A get the same ratio. The cosine of B and the sine of A get the same ratio. And tangent and cotangent are going to be complementary, are going to have complementary angles. The tangent of B and the cotangent of A will be the same, and the cotangent of B and the tangent of A will be the same because they're dealing with the same two numbers, A and B. So that's why they're, and then the reciprocal functions have the same relationship that sine and cosine have. Complementary angle theorem, cofunctions of complementary angles are equal. That's the formal definition of what this slide is showing. So cofunctions, sine and cosine are cofunctions. Secant and cosecant are cofunctions. Tangent and cotangent are cofunctions. And so those cofunctions of complementary angles are going to be equal. So a function of one angle that will equal the cofunction of the complementary angle. So tangent of 30 degrees will equal cotangent of 60 degrees.
Is a theorem and the axiom the same thing? Or postulate?
No, an axiom or postulate is a statement we take to be true.
Oh,
Because we haven't been able to prove it false.
Right. But in that other slide, we just proved this theorem, right?
No, the other slide is an what do you call it?
That's not proving the theorem?
It's showing what the theorem is saying.
Okay, but it's not proving.
It's not proven.
Okay.
And we don't do proofs in this class.
Oh, okay.
Well, not always. Trig identities are proofs.
Yeah.
So the complementary angle here is 11 degrees. 90 minus 79. So that's going to equal the cosine of 11 degrees. The complementary angle here. So what angle adds to pi over 18 to equal pi over 2?
Pi over 16?
Well, that's an 18 down there.
Oh.
So you do pi over 2 minus pi over 18, which is 9 pi over 18 minus pi over 18, right? Because to get an 18 here, I have to multiply it by 9, so I have to multiply the numerator by 9.
Common denominator.
Yeah, I have to get common denominators before I can subtract my numerators. Now 9 minus 1, 9 pi minus 1 pi is 8 pi over 18, which is 4 pi over 9. So the cotangent of 4 pi over 9 equals the tangent of 18, of pi over 18. And we always want to write our angles, we want to write them, our fractions in simplified form, reduced form. Now the complementary angle to pi over 3 is pi over 6. The complementary angle to 5 pi over 12 is 1 pi over 12. Because half of 12 is 6, and I need to add 1 to 5 to make 6. And so this would be secant of pi over 12, and this would be sine of pi over 6. Both sine over 11. And this one done the same way. They solved the same way I did. But they didn't show they didn't show what I showed here. And then here, they're gonna subtract 2 pi minus that. So the common denominator would be 6. So that would be 3 pi over 6 minus 2 pi over 6, which leaves us 1 pi over 6. And then this would be 6 pi over 12 to get us the 1 pi over 12. Why 12? Oh, 12, yeah. Questions on this? Yeah, fractions. You never get away from fractions in mathematics. They're always going to be a thorn in your side.
Especially in trig.
Everything else. So it's good to know how to manipulate them to make them do what so they'll do what you want them to do. All right, so the Pythagorean theorem. And for the two acute angles of a right triangle, they add to 90. And this is straight out of high school geometry. Actually, this part here is, I think you were first introduced to the Pythagorean theorem back in middle school in 8th grade mathematics. Yeah, I know you were. I taught 8th grade for 2 years. It was pure hell. Okay. So B is 4, A is 35 degrees. So I know one angle and I know one side. So this was B here, and this was A over here. I know what B is. What is B? That's easy. What is it?
90.
No,
Oh, what?
90 is over here.
Oh, that's 45.
If
35.
this is 35, what is this
60.
one? 65.
65.
No, it's not. 65 and 35 is 100.
No, then it's
55, thank you. 90 minus. Okay. So then we can use sine of 35 equals well, no, I'm going to do cosine of 35. Cosine of 35 equals B over C. And B is 4, so that's going to be 4 over C. Because now I want to find these two sides. I found the missing angle real easy. Now I need to find these two sides. Well, then that's just solving that equation for C. So I get C times the cosine of 35 degrees equals 4, or C equals 4 divided by the cosine of 35 degrees. And that's a calculator problem. Y'all can't hear me on Zoom?
We can,
Okay. Thank you.
or at least I can. I don't know about the rest.
Yeah. Well, Tyler went away. Okay,
Go back over here. I can't read your writing. What does it
I
say?
can't either. So you punch that into the calculator. What do you get? So type it into the calculator to be 4 divided by cosine 35. First, you need to make sure that your calculator is in degree mode for the angles. So what do we get?
Gotta bring our TIs.
No, you don't have to. I just don't have a calculator.
4 divided by cosine of 35.
Somebody have it?
0.1142. Could be wrong.
Yeah, it's wrong. What? 4.883. And yeah, we'll go ahead and keep the 3 decimal places when we finish calculating the rest of it. And so A, so that gave me C, and for my answer, I'm going to say it's 4.88. I'm just going to two decimal places for the answer, but I'm going to use the 3 decimal places in my calculator. So for angle for side A, I can do the sine of 35 degrees is going to equal A over 4.883. My A looks like a 9. And so in this case, I just need to multiply both sides by 4.883. So 4.883 times the sine of 35 degrees is what A is. So you just punch that in the calculator and what someone get.
Oh, you just gotta.
Yeah.
To get it. 48, 4.8.
What? 4.883 times the sine of 35.
2.800.
2.8.
I don't know, that could be wrong. That wrong?
I got 2.8.
Huh?
I got 2.8.
Okay. What was the next number down? 7, so that would round to a 1.
Or we're going by the thousandths place? Hundredths?
Well, yeah, this is the thousandths place. But you go to the one next to it to tell, are you gonna stay or go up?
Yeah, okay.
And so my answers, I'm rounding to the second decimal place. So this is going to be 2.80. If it rounds to a 0, use the 0, because that tells people you rounded to this number. It's like 7. There we go. So let's see if I did it the same way they did it. I might do it different. They have done it differently. Okay. So they got the 55. Okay. I'm writing there useless. Okay. And so use the fact that tangent is, oh, they did A over 4. Tangent of 45. Okay. And they used cosine of 35. Isn't that what I used? So they did it. What? No, they just.
Oh, they just did it?
Yeah, so here we're gonna multiply 4 times the tangent of 35,
Oh, they just went around. Yeah.
which is approximately 2.80, which is what we got.
Yeah. Never mind.
And then this is exactly how we calculated for C. And they rounded to 2 decimal places, like I did. I like to go, in my calculations, I like to use more decimal places than is required in my answer. It gives you a more accurate answer. So here we have another right triangle, and we do not know what A and B are. So let's see how they're going to find. They're either going to find A first or B first. If they go after A, it's going to be the tangent of A will equal 4 over 2. Or the tangent of B will equal 2 over 4. So tangent of A will equal 2, or the tangent of B will equal 1/2. Well, they use Pythagorean theorem to find this side over here. Well, I forgot that you need to find that there. That's the easy way to go, or easier one to start with. And so 4 squared plus 2 squared square rooted. So we get 20, and then we need the square root of 20. And you simplify the square root of 20 by pulling out the square root of 4 out and leaving a 5 behind. And I'm curious, do they round it? Yes, they do round it. So they type it into the calculator and get 4.47. So the length of this side over here is 4.47. Now they're going to go after finding out what angle A is, because A comes before B. It doesn't matter. And they would use tangent, so that's what I would use. And so a 4/2 is 2. And so they do inverse tangent of 2. You type that into the calculator. And typing that into the calculator, you get the angle is approximately 63.4. Textbooks almost always round well, they go one of two pathways. They round it to 1 decimal place, or they round it to a whole number. Right,
So I've
so,
seen a lot recently that it's going by 2. Like the homeworks, I've seen mostly that goes by 2, like 2 back.
oh, they want 2, and the homeworks, they're going to do 2 decimal places on the angle.
That's what I've seen so far.
Okay. That's more accurate than the 1 decimal place. But. And then this is just, a lot of this is just using calculator. Setting it up appropriately and then using the calculator. All right. And then to find B, you subtract the 360.4 from 90 to get 26.6 to find angle B. And that's what they mean by solving a right triangle, is you're giving certain information about the right triangle, find the rest of it. Okay. Here we go. Straight trail leads from Alpine Hotel, an elevation of 8,000 feet. To a scenic overlook of elevation 11,100 feet.
Well, we can figure out the opposite. Isn't it 11,100 minus 8,000? Get. Oh, they already give it to us, right? 3,100.
Yeah.
Oh, they already gave it.
So we have this length of this side
Yeah, they gave it to us.
is 3,100. That's just simply subtracting the elevations. And the trail, which is, I guess the trail is pretty much straight. I've never come across a trail that is perfectly straight. But anyway, they're saying it's 14,100 feet. So they want to know the grade. In other words, what's this angle? When they talk about a 2% grade, a road is at 3% grade, that means from the horizontal, it's tilted upwards at 3%.
Yeah. You gotta know
So a
that.
grade of that is greater than 12% is dangerous.
That's why the city doesn't allow you to make your, the traffic, I forget, it's text dot, I think, with the permits. They don't exceed 4% the driveway, the grade of the driveway with the sidewalk concrete, something like that. But they have the whole formulas and everything. You gotta make sure that whenever you draw the plans that they're within the grade. Cause they'll get mad at you.
There was a portion of I-90 out in West Texas where the grade was like, it was over 30%. I want to say it was 40,
That's crazy.
45%. Yeah, it was crazy.
That's
nuts.
crazy, Steve.
It was on the side of a hill, of a big hill. And it was a 2-lane highway, and there were truckers coming up and down all the time. And so you're driving downhill and there's a big trucker in front of you and a big trucker behind you, and you're driving a tiny little pickup truck.
Imagine them that have to go up those grades.
I know.
With that load.
So it was scary. Especially when you're driving it at night. Anyway, what do they want to find out? Okay, so they want to know the inclination or the grade of the trail. In other words, what's that angle? Well, I have the length of 2 sides.
Figure out the third side.
No, all I need to do is tangent to B equals the opposite
So
over
with the
that.
J's.
Oh, because that's the hypotenuse. Okay. So yeah, they're gonna do the sine of B to get the opposite over that. Okay. Oh, I got the wrong answer. Okay. So you do the inverse sine to get the angle. So it's approximately 12.7 degrees, which for hiking purposes is getting that's a workout. Let me put it that way. So the inclination grade of the trail is approximately 12.7 degrees. Okay. So, I really don't like this problem. I still do it every time I teach it, but I really don't like this problem. A lighthouse stands 100 feet high on a hill, 300 feet high. Okay, so the total height of the beam is 400 feet above sea level. Well, it is 3,960 miles from the center of the earth. And what they're saying is that they're saying this distance here is approximately 26 miles. Now, the question is, are they meaning line of sight is 26 miles or the length of this arc is 26 miles? And are they talking about miles, or are they talking nautical miles? Number of knots. And those are things to consider. A nautical mile is further than a mile we measure on land. And then we have to convert this 100 feet into how many miles? So it's a decimal number of miles that we add to here.
Version factors.
Yeah, I know, it's crazy. So we don't necessarily are worried about what that angle is. We just want to find out what, well, we do find out what that angle is. So we can find out what, the cosine of theta, which is the adjacent side over the hypotenuse. So we can find out what this angle is, so we can do the dividing 4,000 by 500 by 5,280 converts this to a mile, how many miles it is. And then dividing. So notice it is not very much less than 1. So I would use these 5 decimal places, if not all of these decimal places, to do my calculations with. Because it is so close to 1, might have problems using it. And so solving for theta, we do the cosine inverse of that number. Wait a second. These are supposed to be 9s, right? That's a major typo. God. And so, and now they want to convert, I don't know why they're going to convert it to minutes. Oh, I know why they're going to convert it to minutes. So 60 times this decimal number gives us the number of minutes in decimals. And the brochure does not indicate whether the distance is measured in nautical miles or in statute miles. Calculate both distances. 1 nautical mile is the length of 1 minute. So that 2.7, the 21.7 minutes of that angle measure is how many nautical miles it is. So that means that that part, let me draw it. This part here is the curve, the arc is 21.27 nautical miles, which is really small compared to, but anyway. The distance in statute miles is given by the formula S equals R theta, where theta is measured in radians. So we convert the angle in degrees to radians. So the angle is approximately 0.35440. So you multiply that by pi over 180, and you type it into the calculator, and you'll get this many radians. And then the radians, the number of radians multiplied by the radius gives us 24.5 miles. So in nautical miles, it's just under 22 nautical miles. And in statute miles, it's just 24.5 miles. So the brochure is kind of stretching it a little bit. If they said 25 miles, well, yeah, okay, I can go with that since 25 is rounding this up to 25. But yeah. So they're basically blowing smoke. Now, bearings. Bearings are different. This is what you deal with when you're, the military deals with bearings. If you fly airplanes, you deal with bearings. Bearings are based on, are you going north or are you going south? And how many degrees east or west are you going? And you have to have a reference point because the bearings are based on the origin. So if I'm going in this direction, that means I'm going north 30 degrees east. That's my direction. Now, a precise number would tell you you're so many miles or so many meters or so many kilometers from my reference point, and then the bearing is north 30 degrees east. And with bearings, we almost exclusively use degrees. So bearings are always between 0 and 90 degrees. It's just, am I going north or am I going south? And then how many degrees east or how many degrees west? Am I going north? How many degrees west? How many degrees east? So the bearing from from the origin to an object at P4, well, this is P4, so we're going south 20 degrees east. It's pretty straightforward once you understand what they're doing and what they're talking about. So the bearing is always an acute angle. Less than 90, more than 0. Because if you're going due east or due west, that's what we'd say, due east or due west. So. Oh, I'm not going to worry about this. I am not going to give you this on a test. I swear to God.
Thank you for this. Very, very appreciated.
Yeah. You may end up needing it, but you're not getting it from me. Okay. So, but there will be homework problems over this. So, if you need help with them, I will try. Especially since, yeah, so they're saying, you leave here and you're going after so many minutes, then you turn 90 degrees to the west, 90 degrees going west. And so and then you fly for so many minutes, what's your new bearing? What's your new bearing? Yeah. At this point, what's your bearing? Because your bearing is going to change because you're not flying directly away from your reference point. So your bearing is constantly changing as you're getting further away or coming towards. Okay. So law of signs. First thing we need to know is what the law of signs is. Because with the law of signs, we can solve triangles. Side, angle, side, angle, side. This is a little different than what you had in geometry, where you talked about proving similar triangles and proving congruent triangles. This is finding the angles and the sides. What are those measures?
Yeah, but the side angle, angle, side angle, and side angle, that was geometry too.
Yes, it was.
Yeah.
But now we're looking at it differently,
Okay.
because there's more than one way to look at a pot. One way, the whole thing goes in my mouth. Okay. All right. So side angle, angle, so that means the side is not included. It's a non-included angle. I mean, a non-included side. When it's written side angle, angle, SAA. SASA, angle, side angle, the side is included. That means it's between the two angles. So the two angles share a side. In the side angle, angle, they do not share that side. Only one angle has that side. Okay. And then side angle, that's where you have two sides, and then the angle either comes off of one of them, not it doesn't hit both of them. So it would come off this one. And so, I mean, this side, so you know this side over here, but you don't know this side, either of these sides. And we'll look at those. I'll look at them more closely. So to solve an oblique triangle means you find the length of its sides and the measures of its angles. To do this, we need to know the length of one side along with two angles, or one angle and one other side, or the two other sides. There are four possibilities to consider. The length of one side must be known because knowing only the angles results in a family of similar triangles. So if you don't know the length of the side, then you can get very big or very small, and the shape remains the same. The angles remain the same, but you don't know the side. So you have to have at least one side. Case one side and two angles are known. And in that case one, you have two cases inside that one case. So where the angle is, where the side is included and where the side is not included between the two angles. And then where you know two sides and an angle, where this angle is not included between the two angles. I mean, the two sides. And then the two sides and the included angle are known as side angle side. That means the side is included between the two sides. So those two sides form that angle. And then three sides are known. Well, I want to back up a second. To solve an oblique triangle. An oblique triangle just means there's not a right angle in the triangle. Otherwise, you can use right triangle trigonometry. But we don't know. This is when, so An oblique triangle is either an obtuse triangle or a scalene triangle. A scalene triangle means all the, well, no, not scalene, acute, where all three angles are less than 90. Obtuse means one of the angles is more than 90. And so here we have those three cases, those four cases. Please notice that the first case is split into two different categories. This is where you know two angles in one side. Here's where we know two sides and one angle. And the angle is not included in the two sides. And this one, the angle is included between the two sides, and then the three sides are no. And this is where we start using the law of sines. Okay. For any triangle, this is also true of right triangles. But the sine of A divided by the sine of the angle A divided by the length A is going to be the same as the sine of angle B divided by the length B. And the sine of, and it's going to equal the sine of angle C divided by the length C. So the A, B, and C, the variables are, those sides are opposite this angle. So C is opposite angle C, B is opposite angle B, and A is opposite angle B. So we typically, like we typically write them, if this is A, B, and C, this is A, B, and C. So that's how we typically, but they would put the A, B, and C on the inside. And they're saying that this theorem here, this equation here, formula, is basically three equations, three equalities. And this you should know from a long time ago, is that the three measures inside a triangle add up to 180 degrees.
Sure.
Well, oh. And because of the transitive property and substitution property of equality, instead of writing these three equations, we just write it this way.
Mhm.
Because the transitive property means that the beginning equals the end.
Mhm.
So,
And the end equals the beginning.
Right.
Oh,
what I like to do is to set it up. All right, so I'm guessing this is going to be angle A, this is angle B, this is A over here. Okay, so I set it up. The sine of 45 degrees divided by 5 is going to equal the sine of 55 degrees divided by B. Because 55 is the B angle. And the sine of C over C. So I set this up and I look to see what can I find right away. Well, I can find B. Well, actually, I can find out what C
Yeah,
is.
I was about to say 180 minus 180.
So this is 80 degrees. So sine of C is the sine of 80. Because 180 minus 55 minus 45 equals the 80. So the two equations I'm going to use to solve here is this one and the sine of 45 degrees over 5 equals the sine of 80 over C. So this becomes B equals
5.
5 times the sine of 55 divided by the sine of 45. And this one down here becomes C equals 5 times the sine of 80 degrees divided by the sine of 45 degrees. So doing the algebra, I'm multiplying both sides by C, and then multiplying both sides by the reciprocal of sine 45 over 5
Cross multiplying.
gives, or most cross multiplying and dividing, basically is what you do. And you wind up with this, these two. And so you just punch it into the calculator.
Ooh.
Sine of 45 is the square root of 2 over 2, which is a decimal number for 0.7071. I think, yeah, that's what it is. And so I'm going to multiply 5 times the sine of 55 by the sine of 40. So that's just calculator work.
I got 5.79227 for could be wrong.
So, yeah, so we're gonna round to 2 decimal places for our answer. So it's approximately. Doesn't equal it exactly because we're rounding. And so the other one. Five times the sine of 80.
6.963 or 6.96.
6.963.
Yes.
So we're gonna go to 2 decimal places.
Could be wrong.
So they're doing the same two functions I was doing. Erase everything with my 2 answers that I got. And solving for C. Solving for B and C. B gives us the 5.79, and the C gives us 6.96, which is what we got. I usually go to 4 decimal places when doing my calculations, and then I round my final answer to 2 decimal places. So they got the same number as we have got.
Ooh.
yes, you punched it into the calculator correctly. You always double check yourself when you punch numbers into a calculator.
We
Um,
are fallible.
Yeah. I could have sworn I hit that 5, yeah. So you do the sign of 4 instead of the sign of 4, or
Yeah, messes everything.
yeah. Or you hit the 5 twice. So it's sign of 455. Okay. Now solve the triangle. You know, angle A is 20 degrees, angle B is, what is that, 25
25.
degrees? And you know, one side is 4. So if you know the two angles, what's the third angle? So that's 45, so 180 minus 45.
20.
No,
Oh,
it's one of the 45-degree angles.
20, 25,
I always see angles in terms of the unit circle. So this is 90 degrees here, and I'm going to subtract 45 degrees. So what angle is this? If this is 45 here, what's this angle?
60.
180 minus 45.
80 or
180,
Oh, 180 minus 45.
right? Because these two add up to 45. When you subtract that,
145.
no,
140.
you have a calculator right in front of you, right?
It's not close to 1%.
135.
Yes, 135. Thank you.
I killed him.
Isn't this one of the 45-degree angles?
Yes, sir.
Okay. All right,
No angles.
so we know, yes, we know the missing angle. Okay. So now 3 angles and 1 side. So we set up the. What was the one side we knew? C. So we set it up with sine of C over C equals the 2 sides we don't know. So again, you do the cross multiply and divide, plugging in the numbers we know. And then they do the cross multiply and divide to get these two things here. Or another little trick you can do. I can write this as A over the sine of 20 equals 4 over the sine of 135. And then I just multiply both sides by the sine of 20, which gives me this. Because if you take the reciprocal of both sides, it's still going to be equal. And you could do the same thing here. And so all you would have to do is multiply both sides by the sine of 40, sine of 25, and would give you this. And then just punching it into the calculator and rounding to 2 decimal places gives you what they have there. So the hardest part, I think, for people in working these problems, at least that's the experience I've noticed in the past, is most people can set these up correctly, but then finding the missing value is where the mess up happens. So cross multiply, so you end up with b times the sine of 135 equals 4 times the sine of 25. And then you just divide both sides by the sine of 135 to get this equation here. And then the other issue is punching numbers into the calculator correctly. That's where being in a study group helps, where you practice doing these types of problems. And so you can check each other's work and watch each other doing it so you can see where the problem is. Especially when you're punching in numbers and you're punching in the sine or cosine or whatever, what's happening? Okay, how are you punching it in? That's usually the biggest mistake, is they're not punching, people don't punch it in correctly. So you may think, well, how is that possible? Well, it's possible.
Valuable beans.
All right. Now, solving a side-side angle triangle, we have three situations that can occur. One is that I know this angle and I know these two sides, but this side isn't long enough to hit this third side over here. So it doesn't form a triangle. This side is just left to dangle in the wind. Okay. Or this side is at the correct length that it forms a right triangle. And so A would be H in this case. Yeah, A is H. And so B times the sine of A gives you what the height is, that A side. And then you could use, well, you would use, well, then finding the other sides off of that. And then the third problem, third situation is you wind up with where A is long enough to hit the other side, but not at a right triangle. Then you either wind up with this situation where it's an obtuse triangle, or you wind up this situation where A is long enough, it's long enough to hit the other side, but it's also short enough that it hits the other side in two places. So it forms two triangles. And when solving those problems and I discover I'm going to have two triangles, I'll draw two separate triangles rather than trying to work off of the one triangle. So I don't mix up which one goes to which triangle, which I've been known to do. And I think, yeah, here. Where A is less than B and B times the sine of A is less than A.
Let's bring in some flashbacks.
So you have these two things, these two triangles. Otherwise, it's going to be like this, where A is the larger of the two numbers. If A is the larger of the two sides, then you're just going to have one triangle. But if A is not the larger of the two sides, then you'll either have two triangles or no triangle. Well, or you might have that 90-degree in there. So you still have the three possibilities. But B times the sine of A does not equal that other known side. So here we have A equals 2, C equals 1, and C is 50 degrees. So setting up the law of sines to find out what angle A is. Okay. So 2 times the sine of 50 is what the sine of A is. So we do the sine of 50 times 2 is approximately 1.53. What's wrong with sine of A equaling 1.53? What do you remember about the values of sine? The values of sine, when we were graphing sine functions, what's the smallest sine value? What's the largest sine value?
1.
-1 and 1. Sine has to be between -1 and 1. Here it has it greater than 1. Can sine be greater than 1?
No, sir.
The only way it can be greater than 1 is if you're multiplying by something, but we're not multiplying by something over here. So this won't happen, not for A. So we don't have a triangle.
Yeah, and we have that. No
Where
solution.
this side is just left swinging in the wind because it'll never hit this side.
And we can't figure out how long B is because it doesn't connect with,
Let's see.
yeah.
But it doesn't form a triangle, so there's no worry about what you need to find or not.
No solution.
No solution. So now we have this one where A is 4 and B is 3 and A is 60. And so we have this situation. Well, this side is longer than this side. And so it will form exactly one triangle. And so then we just use the law of sines to find the missing pieces. And the fact that all 3 angles have a better name. And so the sine of A, which is 60, divided by A, will equal the sine of B over here, divided by 3. And so we take 3/4 of the sine of 60, which is 0.65. And we do sine inverse 0.65. So sine inverse of 0.65 is 40.5. And so we're looking at one angle being 40.5 and possibly the other angle, if we do 180 minus 40.5 and get a, I don't know why they did it this way. So for that angle is discarded because the sum of the angles in a triangle must equal 180 degrees. And 60 plus
Where?
what?
Where's the 180.5 or the 139.5?
That's 180 minus.
1.4.
Where did you get that from? Where did you get the number? The 45?
Oh, this, the 40.5,
Yeah.
arc
Where
sine,
did that come from?
sine inverse of this number. They didn't,
Okay.
they didn't show it, they should have. So, yeah, that's where, let me back up to here. Here I would do the sine inverse of 0.65, which they get to be 40.5. All right, there are two angles that have the same sine between 0 and 180. One of them is 40.5, and the other one is 180 minus 40.5. So this angle, so they're doing the subscript to distinguish between the two angles that are B. So B sub 1 is 40.5, and B sub 2 is 139.5, because the sine of those two angles is the same. That's why they do the subtracting from 180. And so the sum of the three angles has to be 180. But right away, seeing that 60 plus this is going to be more than 180. So we can't use this one. So it has to be that one. So angle B is the 40.5. And so subtracting the 60 and the 40.5 gives us 79.5. And so the three angles are 40.5 degrees, 60 degrees, and 79.5 degrees. And then we start dealing with finding the third side. So sine of 60 over 4 equals the sine of 79.5 over C.
And then 4 times.
That's not clear to me. Go back a little bit.
To where?
For the secant.
The sign of C.
Sine of C. How did you find that?
Well, we found it over here. Angle C is subtracting A and B from 180.
Oh,
So that's how they got angle C. Okay. And so then you just do the cross multiply and divide to get that C is 4.54. So how I typically do these, we say A, B, and C, those equal, and then A, B, and C. They equal. A, what was angle A? Angle A was the 60 degrees. B was the 40.5. And the C is the 79.5. And A was 4. And B was 3. And C was 124.54. So on the exam, when you get this type of problem, you either write your answers this way or you write it in the triangle. I prefer this way mainly because if you have two different angles for angle B, which means you're going to have two different angles for angle C, and you're going to get two different measures for length C. So you have one here and the other one next to it, rather than trying to put it all in one triangle. So here we have two sides and a non-included angle. So the sine of 40 over A over 7, sine of 40 over 7 will equal the sine of B divided by 9. Because I know what angle A and what side A, those measures are. And I know the measure of B, so I can find the measure of angle B by solving this for sine of B and then just doing the sine inverse. Okay, so I multiply both sides by 9. Multiplying both sides by 9, you get this expression. This is wrong. That's wrong. If they're going to throw a sine inverse, they have to do sine inverse of this will equal B. But that should be sine of B. And then do the sine inverse of this number. The sine inverse of this number will give you 55.7 degrees. Or B can be 180 minus 55.7. So you have these two potential angles. This one definitely will work, but now I need to see if this one will work. Because 40 plus 124 is less than 180. So both angles can work. So you get two triangles out of this. Well, you understand that both 55.7 and 124.3, the sine of those two give you this number. The sine of this angle is 0.83, and the sine of this angle is 0.83. So it could be both of these angles. So we want to see, can it be both of those angles? So we would have two separate triangles. One where angle B is at 55.7 degrees, and one where angle B is at 124.3 degrees. So to see if it can be this one, so we do 124.3 plus 40, because that's the other known degree, and that equals 164.3 degrees, which is less than 180. So I have enough room for another triangle, for another angle in that triangle. So I subtract this from 180, which is what? 15.7 degrees. So 15.7, 40, and 124.3 form a triangle. Because they all add up to 180. And with this one, I do the 40 plus the 55.7 gives me 95.7 degrees. And so that means an 83.3 degree angle needs to be, so you have, so this one is in a obtuse triangle, I mean in a cube triangle, and this one will be an obtuse triangle because I have one angle greater than 90. So far we have angle A with angle B sub 1. Angle A is 40, angle B sub 1 is, what was that, 55.7. And then angle A still is going to be 40, but now angle B,
So after you do the 0.3, that 0.1 and the 5.7.
So when we've got the sign there for the first one, tell me how when we're using, where are we getting 56 from? I thought it should be 75.7, no?
what was 45.7?
Oh, the sign, the inverse sign is 56.098. You put it on the calculator?
So the inverse sign of this,
Yeah,
so they're wrong.
it's not 83. I think so, yeah. Looks like it's wrong. When you punch it in on the calculator, I'm not
So
getting
9
83.
times sine of 40
Uh-huh.
divided by 7, what do you get? Because they're not beyond being wrong. Especially since this is a new edition of the textbook.
I did it and it's 0.826.
82.6, which rounds to 83.
Yes.
Okay.
Okay. It's the 55.7 that's confusing.
So now, this is a typo, that's not there. So the sine of B equals this number. So I do sine inverse to give me what B is. So the sine inverse of 0.83, did they do it correctly?
I did it and it's 56.0.
Okay, so they probably use, what'd you get? 82 point what? 6 what?
64.
64? I would use this to do the inverse on. So is that closer to the 55.7? Okay. Yeah, use more decimal places than what they're showing here. Yeah, I like using 4 decimal places because it's more accurate than the 2 decimal places. So the sine inverse of 82.64.
Sir,
Yes,
I have just Nova at 4. It is 3:40. I'm gonna have to go. I apologize.
okay.
This will be on YouTube though, correct?
Yeah,
Wait, when does class end? Does it end at 40 or 45?
what?
Does class end at 3:40 or 3:45?
Right, 3:40, yes, and I haven't been keeping track of the time.
Oh,
Okay.
all right, then see you on Wednesday. Oh, wait, no, Thursday.
Thursday,
Have a good day.
you too.
You
4.3. And C, so, and then we have two angles for C, and one of them is 83.3 degrees, and the other one is 15.7 degrees. And then you do the sine. And then all we need to do is find the two sides, I mean, the two different C values. Because A is gonna be 7 in both cases, and B is gonna be 9 in both cases. But we're gonna have two different C values for the third side. And so you do the sine of the, to find them. So sine of 40/7 equals the sine of 83.3 over C sub 1, and then the sine of 40/7 equals the sine of 15.7 divided by C sub 2. I should have been at 2 here. So you get the two angle measures, I mean, the two sides from that. We'll start with this slide next time. And hopefully I can confuse you more.
Sir,
Yeah,
I sent you an email,
when,
Friday in the morning. I couldn't turn in on all the,
you can do it now.
I can turn it in right now? Because I sent you an email with it, the PDF attached, but
No, and I don't want it that.
you don't want it that way. Okay. And I also have it on all